Alright, this is for the last topic of the Mechanics 2 module. It's about centrifugal forces. Okay, so the idea is that if an object of mass m, right, is undergoing a circular motion, it will have a centrifugal force, okay, and a centripetal acceleration. Looking at this diagram, the r is the radius. Okay, if it's undergoing this path, right, you can say that the centripetal acceleration, right, is actually the r omega square. Okay, or if you have velocity, then it's v square over r. Okay, the v in this case is this velocity here that is traveling. Okay, this is r, we know, and the omega is the rotational speed, that is in radians per second. Okay, if the rounds revolutions per minute is given rpm, how you convert to radians per second is just let's say x rpm, right, is x times 2 pi over 60. You will get radians per second. I think the light is a bit flickering, so let me just try to turn it off. Okay, so where exactly is the direction of the centripetal acceleration? Okay, the direction is towards the center of rotation. So in this case, right, it is actually this direction. This is your acceleration. Okay, as in Newton's second law, sum of forces equals to mass times acceleration, right? So what this means is that as long as it's undergoing a circular motion, right, there will be a force that contributes to your acceleration that is directed towards the center. Okay, so let's say, take for example, you have a bucket, okay, and you spin it, right? You have a bucket and you spin it in a circular form. What is the reason? Okay, the reason that provides the acceleration towards the center, that gives you mr omega square. What is the reason? The reason for this case, right, is your tension. Okay, the tension is giving is the force, because it has the same direction towards the center. The tension is mr omega square. Okay, for a vehicle, okay, for a vehicle, let's say top view, the vehicle, okay, is driving in a circular path. So what is the so-called reason that causes the centripetal acceleration towards the center of the circular path? Okay, the reason is the friction. Okay, the frictional force is towards the center also. So this friction is your mr omega square. Okay, for some aero students, you might be interested. You might know also that there is when the plane is banking, no, when the plane is making a turn. Again, from the top view, it looks like this, right? So there must be a reason, okay, that contributes to the centripetal acceleration. If you look from the back, right, the back of the plane is actually doing a banking, correct? So this is the vertical orientation, right? So actually the plane needs to do a bank, and when the plane banks, right, this is your weight, correct? And in fact, then this is the direction of your lift. Okay, because of this lift is actually not totally vertical, it has a horizontal component. This horizontal component, okay, let's just call it L sine theta lah. Okay, so let's say this is theta. This horizontal component is the force that go towards the center of the circle. Okay, because of this component, you have r omega square. So in summary, right, there must be a certain force that causes the object to move in a circular motion, and this force will be equals to mr omega squared. Well, let's talk about the questions in the next video.